Hey, IQ Kid here to talk about the first of the gas laws, Boyle's Law. So to start, let's review the gas laws. So there's Boyle's Law, which is what we're doing today. And then there's Charles' Law, Avogadro's Law, and finally the ideal gas law. Okay, so let's go ahead and talk about gases, so that way we can have the background knowledge we need to deal with Boyle's Law. So the basic gas properties are pressure, which we represent with a capital P, volume, which we represent with a capital V, temperature, which we represent with a capital T, and finally the amount in moles, and we represent that with a lowercase n. Okay, so all of these properties are interrelated, and the gas laws tell us how. So now let's go ahead and look at Boyle's Law. So with Boyle's Law, the relationship between the basic gas properties is the volume is proportional to 1 over the pressure, and this is at constant T and N. So what exactly does this mean? Because I know for some of y'all that would be a little bit confusing. So to put that into words, if the temperature and the amount in moles of a given gas are constant, so T and N are constant, then the volume of that gas is inversely proportional, which is that's the proportional symbol, and inversely means 1 divided by the other. So you'd have V is proportional to 1 over P. Directly proportional would mean just the functions or the variable or whatever, like P. So if volume were directly proportional to pressure, which it's not, but if it were, it would be V is alpha, that's the symbol alpha, P, instead of 1 over P. Okay, so this is the equation we can use to do the math and the chemistry behind it. And so P1 V1 is equal to P2 V2, and that equation right there is basically saying the initial pressure multiplied by the initial volume is equal to the final pressure multiplied by the final volume. So basically you're just looking at the change, really. You're setting aside the change, but it's the same gas. You're not going from, say, CO2 to SO3. You're not changing gases. It has to be the exact same gas, and it has to be the same sample, just certain factors like the volume and the pressure are changing. So we can represent this relationship with arrows. So when the volume is increasing, the pressure is decreasing, and if the volume decreases, then the pressure increases, and vice versa. So if the pressure decreases, then the volume increases, and if the pressure increases, then the volume decreases. And this is only applicable at constant temperature and amount in moles. Okay, so now that we've covered Boyle's Law, let's look at a couple examples. So in this first example, we have a sample of CO2 gas with a pressure of 55 millimeters of mercury. That's what mmHg means. And this is in a volume of 125 milliliters. And so then we compress this to new pressure of 1.04 times 10 to the fourth pascals. That's what the PA means. And that's another measurement of pressure, just like millimeters of mercury. So the question is, what is the new volume? So step one is to convert to have the right units of measure. So we need to convert 1.04 times 10 to the fourth pascals to millimeters of mercury. So the conversion factor is 101,325 pascals is equal to 760 millimeters of mercury. And by the way, this is also equal to 1 atm or 1 atmosphere, which you will also use commonly. So the conversion, you will get 78.006415. So that's not with correct significant figures. So I'm going to put a line under the one that has that to keep track of significant figures. Okay, so then step two is to write the formula. So P1 V1 equals P2 V2. Okay, and now let's move on to step three. In step three, we're going to plug in our values into the equation. So let's write the equation again. P1 V1 equals P2 V2. Okay, so to plug in, our initial pressure is 55 millimeters of mercury. And then our initial volume is 125 milliliters. And that is equal to 78.006415 millimeters of mercury. That's our final pressure times the final volume. So then we can reorder this so to isolate the final volume. So final volume is equal to the initial pressure, so 55 millimeters of mercury, times 125 milliliters, the initial volume, divided by 78.006415 millimeters of mercury, the final pressure. Okay, so then we get for V2, for the final volume, we get 88.1337772 milliliters. So then we need to keep track of sig figs, significant figures. So our final answer is going to be 88 milliliters because we have the 55. So that's the final answer. Okay, so now that we've done that example, let's go on to another example. In this example, we have a sample of SO3 gas and a volume of 35.0 milliliters, and it's expanded to a pressure of 745 torr, and which is another measurement of pressure, and a new volume of 0.0500 liters. What was the initial pressure in millimeters of mercury? So step one is to convert. So we're going to convert torr into millimeters of mercury. So 1 torr is actually equal to 1 millimeter of mercury. So that makes that really easy. So then it's just the same number, 745 millimeters of mercury. And then we also need to convert to have the same value for our volume. So 0.0500 liters times 1,000 milliliters over 1 liter is equal to 50.0 milliliters. Now some teachers are going to want you to work in liters because the ideal gas law deals with liters, but it's easier to work with this number. So if they don't, great. If they do, it's not that big of a deal. just go with it. So then let's write the formula. So P1V1 equals P2V2. Okay. And lastly, step 3 is to plug and chug. So let's go ahead and write the formula again. P1V1 equals P2V2. So let's plug in. So the initial pressure is what we're trying to find, times the initial volume that we converted to get, so 50 milliliters, 50.0 milliliters, is equal to the final pressure, 745 millimeters of mercury. We also converted to get that, times the final volume, which is 35.0 milliliters. So then P1 is equal to the final pressure, 745 millimeters of mercury, times the final volume, 35.0 milliliters, all over the initial volume, so 50.0 milliliters. And then let's solve. So P1 is equal to 521.5 millimeters of mercury. And we need to keep track of sig figs, or significant figures. So if you look back, you're going to need only 3, or you're gonna only have 3 sig figs. So your final answer is going to be 522 millimeters of mercury. Okay. I hope this helped. I know a couple of y'all were having trouble with this. It's pretty easy to mix up with the other laws, but yeah, so I hope this helped, and if you have any questions or you need any help with anything, feel free to contact me. I'll put my email in the description, and I also have a website, which I'll put a link to that in the description. And yeah, iqkid signing off.